So we have been told that the figure below shows a displacement time graph for a progressive wave. You can see its displacement against time, and this is our wave. So the first question, we are told to state the amplitude of the wave. Now before we state the amplitude of the wave, we have been told that these are displacement time graph for a progressive wave, and we can see the type of this wave is a transverse wave. It has crest and troughs alternating. So it is an example of a transverse wave. So we are told to state the amplitude of the wave. So the first thing we need to ask ourselves, what is amplitude? We say that amplitude is the maximum displacement from the mean position. And our mean position is this point here. So the maximum displacement, and remember we said that the SI unit for amplitude is meters. So from this we can see clearly that the maximum displacement on either sides is 2. So our amplitude is 2 and the units are centimeters. So we convert it into meters to make it in its SI unit. And we know that 100 centimeters make 1 meter. So we are going to have it as 2 all over 100, which is 0.02 meters. So that is the amplitude of the wave. We move on to part 2. We are told to determine the frequency of the wave and its 4 marks. Number 2, determine the frequency of the wave. And in this exam, it was 4 marks. Now, we need first to know, what did we say its frequency? Frequency is the number of oscillations in 1 second. Number of oscillations in 1 second. So if we look at our time here, there is nowhere we have 1 second. But we can see clearly, we can calculate how many oscillations are there in 55 seconds. Then we ask ourselves, what about in 1 second? So we want to calculate the complete or the number of oscillations in 55 seconds. So we start from here. We don't start here, we start where the wave begins. So if you look at this part, this is a quarter of a wave. Because if it were on this other way, then this will be another quarter making a half. So this is a quarter, this is a half, this is a half, this is a half, this is a half, and this is a half. So a half plus a half, that is 1, plus 2 halves, again those are 2, 2 and a half, 2 and 3 quarters. You can see clearly that this is 1, 2, 2 and a half, 2 and 3 quarters. So we can say that 2 and 3 quarters oscillations are covered in 55 seconds. And since we are saying frequency is the number of oscillations in 1 second, so we ask ourselves, what about in 1 second? How many oscillations are those? And that is our frequency. So we are going to have it as this, 2 and 3 quarters. 2 and 3 quarters is the same as 2.75 multiplied by 1 divided by 55. So what we end up getting as our frequency, you can use your calculator. So we have 2.75 divided by 55. So we end up getting our frequency as 0.05 hertz. So that is the frequency of the wave. Number of oscillations in 1 second. Part 3 of the question, which is the last part of this question. So part 3. So that is the other part of the question. We are told that given that the velocity of the wave is 20 meters per second, determine its wavelength. So in this, given that the velocity is 20 meters per second, determine the wavelength of the wave. And we know that we had calculated the frequency already. So our frequency, we had gotten it as 0.05 hertz. So we want to move ahead and calculate the wavelength. And since we have the speed and we have the frequency, we can apply the wave equation. So we come and apply the wave equation. Apply the wave equation to relate frequency and wavelength. So our speed is frequency times wavelength. So is 20, our frequency is 0.05. We want to calculate the wavelength. The two are in their SI units, and therefore the wavelength will also be in its SI unit, which is meters. So we have 20 equal to 0.05 by wavelength. So to make wavelength the subject, we divide both signs by 0.05 by 0.0. So we'll end up getting our wavelength to be 20 divided by 0.05, which is the same as 2000 over 5, which is the same as 400, and these are meters. So our wavelength therefore is 400 meters. So that's how we calculate wavelength from the wave equation. V is equal to frequency multiplied by the wavelength. Hopes that question is clear. So it was one question carrying, those are 4 marks plus 3, 7 plus 1, 8 marks on waves 1.